Hello everyone, this is Fatehla Lohar, Assistant Professor, Department of Electronics and Communication at Engineering College, Jalawad. This lecture prepare for RTU syllabus, Radar and TV Engineering for 8th semester EC student. In this lecture, we will discuss about radar systems. Okay, what is the radar and type of the radar and type of the applications and discuss different component of the radar system. Okay, so what is the radar? Radar is a radio detection and ranging. Okay, basically this is the electromagnetic system for detection and location of object on a target like the aircraft, ship, spacecraft, vehicle in nature environment. Radar can operate in darkness, fog, rain and snow. So this radar system can be used for any type of the environment. Okay, it may be used for radar in night, in day, in rainy seasons, in snow, fog seasons. Okay, this is the, so you can see this image. This image represent the movement of the radar antennas. Okay, or the display is represent the target appear in particular range. So this dot, the dot it represent the target. Okay, this image represent the simple antenna transmitted signals and receive a signal beam. Okay, in this range the target we can detect. This is basic principle of radar. You can see this animated images. In this image you can see this is the target. This is the target. In the target may be aircraft, any vehicles, any moving object or a stable object. So many kind of the target may be possible. This is the receiving antenna or a transmitting antenna. Single antenna can be work as a transmitting and receiving. Okay, the signal can be transmit from the antenna and signal can be received from the same antenna. And after receiving signal, the signal is reach the duplexer. This is the point represent the duplexer. Duplexer basically a switch. Okay, at one time the signal can be transmit or a signal can be received. This is the transmitter and this is the modulator and master clock used for the calculating time duration between transmitted and receiving signals. This is receiving signal. First we generate the signal and signal modulate. Okay, after modulation the signal is sent to transmitter. In transmitter their signal, we have to improve the signal power through the power amplifier, and then we send to the duplexer and duplexer sent to the antenna and antenna sent to the target toward the target directions. Okay, after incident the target, the signal reflect back to the antenna directions and then receive the signal, and at this point the duplexer switch switch the power toward the receiver sides and switch off toward the transmitter side. So we receive the signal and then display the signal. Display may be the different type of the display. Okay, it represent the range, velocities, azimuth angles, elevation angles. Okay, so concept in this, suppose the range of the target is determined by the measuring the time it takes for the transmitted signal to travel the target and return back to radar. If TR is the time of the radar signal to travel to the target and return back to the radar, and R is the range of the target from the radar. So the velocity C equal to 2R divided by TR. 2R total journey distance and TR total duration time from transmitted and receiving signals. So using this formula we can calculate the range of the target. So range R equal to CTR divided by 2, where C is the velocity of the light. Okay. So this is basic principle to calculate the range of the object. Okay. Now we discuss this is the basic block diagram of the radar system. Okay. So we start from the transmitter sides. First, pulse modulator. The sinusoidal signal is modulated by the pulse modulator. After pulse modulator, the signal sent to the transmitter. Transmitter contain amplifier, okay, high power amplifiers, and then after enhancing the power of the amplifier from the amplifier sides, we send to the duplexer. Duplexer basically switching purpose, and then we send to the radar antenna. Antenna sent to the in free space toward the target directions. Okay, so you can see this is the TX signals. Okay, and this is the target. After inciding the target, the TX signal, the signal reflect back and reflect back to the antenna side. This is the reflect signal. The signal received from the antenna side and come to duplexers, and duplexers switch the signal direction toward the receiver side and switch off the toward the transmitter side. So signal is come to at the low noise amplifier. After removing the noise in the signal is come to at mixer. At mixer, the local oscillator signal also come at this point, and then after subtraction of the signal, we get the constant IF signals. Okay, constant IF signals. The IF signal, intermediate frequency signals. This IF signal is sent to the IF amplifier. Okay, and then we send the demodulator. The signal is demodulated. Okay, and then we send the video amplifier. Video amplifier, the signal video amplified by the CRT amplifier. Okay, enhance the signal video qualities. And then threshold decision. The threshold decision is analyze the signal target appear or not appear. Okay, then we send the output display. Display represent the different display may be used for the different purpose. For the A scope display, B scope display, PPI display. Okay, depend on the which parameter we need to calculate. For calculation of velocity, for calculation of range, for calculation of azimuth angle, elevation angle. Okay. So in this slide we discuss the different component of the radar system. Okay. First, transmitter. The transmitter part is consist of the basically high power oscillator and high power amplifier, microwave amplifier, a microwave oscillator. Okay, you can see this image represents the magnetrons. Okay, basically this magnetron represent oscillator. It generates high power microwave signals. Okay, and this image represents the microwave high power amplifier. This TWT, traveling wave tube. This is traveling wave tubes. amplifier. Okay. And next part is antenna. So basically for radar system we need high gain and high directivity antennas and high power handling antennas. So this type of antenna we use generally the reflector antenna. So you can see this is the reflector antenna. Okay. Next part is duplexer. So we already discussed duplexer. Basically duplexer is switching network, micro switching network. So first you see in this diagram how a duplexer work. This is antenna, this is a switch duplexer, or this is a transmitter and receiver. When signal we transmit to the duplexer, first if we signal transmit toward the antenna, then duplexer is switch on for the transmitter and switch off for the receiver sides. A similar case, when we receive the signal from the antenna, then we switch on toward the receiver sides and switch off toward the transmitting sides. So basically this is the purpose for switching purpose. Using the duplexer, the same antenna can be work as a transmitting and receiving. Otherwise we have to use two antenna. One antenna for transmitting purpose or other antenna for use for the receiving purpose. Okay. Receiver. The receiver section of radar system is always a super heterodyne types. The receiver may be super heterodyne, including the oscillators. The input RF stage can be low noise transistor amplifier. The mixer and local oscillators convert the RF signal into intermediate frequency signal. In some radar applications, the low noise input stage is excluded and the mixer become a first stage of receiver. A receiver with mixer as the input stage becomes less sensitive because of the mixer's higher noise figure. A mixer has greater dynamics range, less vulnerability to external electromagnetic interference, and less susceptibility to overload. The fifth component, IF amplifier, the intermediate frequency amplifier, boosts the mixer's output at the intermediate frequency without any distortion in the pulse waveform. The signal bandwidth of a superheterodyne receiver is defined by the bandwidth of its IF stage. The center frequency of typical IF amplifier is in a range of 30 to 60 MHz, while the bandwidth is of the order of 1 MHz. Detector. The IF amplifier stage is followed by a second detector or demodulator. A diode detector may be used for the demodulating or detection of the transmitting signal. The combination of IF amplifier, demodulator and video amplifier act as an envelope to pass the pulse modulation and remove the carrier frequency. Video amplifier. The role of the video amplifier in the radar's receiver is to provide sufficient amplification or to increase the level of the inputs signal to the magnitude where it can be seen easily or a cathode ray tubes. Display the signal from the video amplifier is given to the threshold decision, which decide whenever target is present or not. The decision is based on the magnitude of the received output. Okay. So display can be the further divided into the three types: I scope, B scope, PPI. PPI means plane position indicator. A scope display. The A scope display represent a target signal amplitude versus range of velocity. The display a target along pencil beam for selected range limit. B scope, the range versus azimuth elevation angles. Display target within the selected limits. PPI. This is the common display generally used in radar system. Plane position indicator. The plane position indicator is the most common type of radar system. The radar antenna is usually represent in the center of the display, so the distance from it can and the height above the ground can be drawn as concentric circles. A radar antenna rotates as a radial trace on the PPI sweep in unison and with and about the center points. Basically, this display is calculate range and angle, elevation angles basically. Now in this slide we discuss the application of radar system. The radar play important role of military purpose, although it has been employed in the civilian applications. Military applications, detection and ranging of enemy target even at night. In air defense systems, operation of offensive missiles and others weapons. In missile system for the guidance and fudging of the weapons. Early warning regarding the approaching aircraft or a ship. Air traffic control ATC. This type of radar system is available in every airports. Okay. The radars have been employed throughout the world for the safety of aircraft and controlling the air traffic. It is also used for the guiding aircraft to safe landing during the distributed weather. Other applications, the radar speed meter is used police for the enforcing the speed limit. In ship safety, radar is employed to avoid collision when visibility is poor. The radar are used to indicate region of the precipitation height of the aircraft above the terrains to avoid the hazard related with them. The space vehicle have used radar for reconnaissance and docking for landing on the moon. The next concept we discuss the maximum unambiguous range. Okay. The unambiguous range basically represents the maximum unambiguous range is defined by the range beyond which the target appears a second time around the echoes. Basically, the unambiguous range represents the target appear in second times after sending the signal. Okay. The signal is radiated into the space is form of the pulse modulated signal sine wave. When the transmitted signal pulse radiated by the radar, sufficient length of the time must be allowed so that all the echoes signal due to this pulse may be returned back to the radar before next pulse is transmitted. Consider R is equal to CTP by 2. C is velocity of light, R is a range, unambiguous range. Okay. TP pulse repetition period can be defined in terms of the pulse repetition frequency. R unambiguous range, C divided by 2 FP. FP is a pulse repetition frequency or a period. TP is period, FP pulse repetition frequency. So you can see this is the first TX pulses, transmitted pulses, or this is the second TX pulses, or second time around the echoes signals. Okay, so to next lecture we discuss the some type of the radar, MTA radars, pulse radar, and also we will discuss the Doppler effect. This principle used for the continuous radar systems. Okay.